Welcome to the now 21st annual workshop on computational cell biology held here at the Center for Cell Analysis and Modeling at the University of Connecticut School of Medicine. I'm Ann Cowan. I'm part of the V-Cell team and wanted to welcome you to the workshop and give you a little overview of what will go on over the next 3 days. This is our first year as an online workshop. Past events have been held on site here at the Center for Cell Analysis and Modeling, but we're limited to about 10 participants that we worked with to side by side to help build their models. So we ask you all to please bear with us as we adjust to this new online environment for the workshop. And some 70 people from around the world. So the workshop provides an introduction to different types of mathematical modeling software. In particular, different types of mathematical modeling related primarily to cell biological problems. And it features 3 major software environments associated with our center. And I'm going to tell you a little bit about each of those. Those are Virtual Cell, Copasi, and Spring Salad software. So the Virtual Cell software allows different approaches to dynamical modeling, but starting with the same underlying biological model. So you describe the biology, which we call in Virtual Cell the physiology, and then you can apply different types of modeling to that particular biology. And we have both non-spatial or what's called compartmental or ODE-based models that do not include space. And you can use the same biology to then run a spatial model that incorporates diffusion and transport of molecules using PDE, partial differential equation approaches. Virtual Cell also allows you to apply rule-based approaches to models as well, and can provide a variety of solvers, including stochastic, deterministic, and hybrid stochastic deterministic solvers. It also provides network-free solvers for rule-based approaches. We also, in Virtual Cell, have parameter estimation available using the tools from Copasi. I'll talk about in a minute. And importantly, Virtual Cell allows direct import of experimental images to create geometries for simulation. So, and this allows direct comparison of your results, the results of a simulation to experimental results obtained in a microscope. Copasi is one of the major software components used for dynamical modeling in biology using either ODEs, ordinary differential equations, or stochastic methods. And this modeling can be either time course or steady state analysis. It allows for a wide range of solvers for deterministic, stochastic, and hybrid methods. And it also has extensive tools available for analyzing the models developed. And these include things like parameter optimization, sensitivity analysis, metabolic analysis, and stoichiometric analysis. Finally, the final type of software we'll be presenting in the software is Spring Salad. Spring Salad is what we call a mesoscale modeling software regime, which uses a very coarse-grained molecular dynamics simulator for simulating subcellular reaction diffusion models. It's a particle-based simulator that accounts for molecular spatial constraints and crowded environments. In the Spring Salad, the molecular sites on a molecule are modeled as impenetrable spheres that are connected to other sites by stiff springs, and all the sites are allowed to diffuse. It uses rule-based modeling approaches to develop the model itself. And because it works on such a small scale, it's very compute intensive, and so it can be very slow to solve particular reactions, and thus it's limited to very small regions of a cell, and usually pretty short time scales. So those are the 3 types of software that we'll be using in the workshop. I'd like to also introduce the team from that's going to be helping with the workshop. These include developers, faculty, students, postdocs, and people who have worked on development of both of all three software, VSAL, Kapasi, and Spring Salad. And I also wanted to highlight Clarissa Trudell, who's involved in our IT operation here and has been really instrumental in helping with the Zoom recordings and creating all of the online help that is available related to the symposia online. Also wanted to point out that we have general resource information here on this slide. So that includes where you can find and download and find support for all of the three software offerings. Also to point out that we now have a comp cell biology channel in YouTube where all of the videos from the presentations will be provided. And we created a drive for sharing that with workshop information that will be moved over to the one of the websites or both websites after the symposium, after the workshop is finished. Okay, and this material includes material that is associated with many of the presentations that will be given during the course of the workshop. And so this will be available to you initially on this shared drive, but eventually on the website. Just a word or two about how the symposium, the workshop is organized. We have two tracks. One of the tracks is a project track, and these participants are people that have a particular modeling problem that they brought with them and want help to solve, and is therefore limited to just allow us to really help those people individually. And we have pre-assigned all of the project track participants to breakout rooms with several instructors. The assignments are based on having projects with similar styles of modeling to be in the same room with instructors with the appropriate expertise. So if you think we've somehow put you in the wrong room, please let us know. Also note that several instructors will roam from room to room because everybody has overlapping expertise. And finally, if a particular person's expertise is needed who's not in the room, we can call that person to the room using a help option in the breakout rooms to call Clarissa, and she'll go get them and bring them into the breakout room. So hopefully everybody will get the expertise that they need. And also that we'll try to make sure that each participant in the room will have time to share their screen with the room and get help developing their model. And we'll try to ensure that that's relatively evenly distributed among the participants. Finally, the main room in Zoom will be open for sidebar conversations. Just a word or two about how the schedule works. So it's a 3-day workshop. It runs from pretty much 9 o'clock. Today starts a little late, but 9 o'clock in the morning until 6 o'clock in the evening. And the main symposia, to which everyone is welcome to, take place in the middle of the day, so we can accommodate the multiple time zones involved in this. So today, for example, after my overview, there'll be an introduction to reaction kinetics and diffusion from Les. I'll give a tutorial on virtual cell, and Pedro Mendez will give a tutorial on Kapasi. Similarly, there'll be tutorials on Tuesday on stochastic simulations, deterministic spatial simulations, and Spring Salad, and more on Wednesday for rule-based modeling and parameter estimation. So everyone is welcome to join us for the symposia. The project track participants will move to the breakout rooms after the major talks today. So the project tracks are usually in the afternoon and in the early morning, where everyone will go to the breakout rooms and will help people develop their own models. And then we also hold symposia that have the project track participants present some of their modeling efforts, and in particular trying to highlight particular aspects of the software that they've found essential to modeling their particular problem with. And we highly encourage everyone to join in the symposium, because this is really the meat of how modeling gets done. And so how you can see how certain problems are addressed with each of the different kinds of software. And then finally, again, we welcome all to come to an open forum that we use to get suggestions for new functionality for the software, additional questions that haven't been answered yet, or complaints about bugs so that we know which ones to fix first. And we write down all of the suggestions and bug lists and use those to help improve all of the software. So we strongly encourage everyone to come to the open forum as well. And then finally, Wednesday at 6 o'clock is the end of the workshop. So that's the end of my slides. Again, welcome, and we'll move on to the next presentation where Les will talk about the basics of reaction kinetics and diffusion.